Hey guys, it's Miss Adams, and we're still looking at the Unit 5 test review, and we are looking at our applications with geometric sequences, and we're going to look at problem number 18. So in problem number 18, Mario is training frogs to ride scooters. He has 3 frogs right now, but the number of frogs he has seems to double each month. So I got to initially decide where is he starting and then what is he changing by. So I know he starts with 3 frogs. That's going to be my initial value. And then it tells me that he doubles every month, so my common ratio is 2. Part A then asks me label the X and Y axes with the appropriate units. Can we change time? Absolutely not. So that's going to be our dominant axis. That's going to be our domain, so that's our X axis. So we're going to have the number of months as our X axis. And then the number of frogs then will be our y-axis. Then it says plot the number of frogs riding scooters over a 6-month period. To make this a little bit easier, I'm going to go ahead and make an X and Y table. And I know that my domain is going to be 1, 2, 3, 4, 5, 6, because it's asking me for 6 months. I know my first month I'm starting off with 3 frogs. If I double that, I'll have 6 frogs. 6 times 2 is going to give me 12 frogs for the 3rd month. My 4th month is going to be 12 times 2, which is going to be 24 frogs. My 5th month, I'm going to double 24 to give me 48 frogs by the 5th month. And for the 6th month, I'm going to double 48, which will give me 96 frogs by month 6. I can then plot these values. So, month 1, I've got 3 frogs. Month 2, I've got 6 frogs. Month 3 is 12 frogs. Month 4 is 24 frogs. Month 5 is 48 frogs. And month 6 is 96 frogs. So notice that does increase exponentially. Part C says write a recursive formula for the situation. I already know my initial value was 3. So my recursive formula would be a sub n is equivalent to a sub n minus 1 times my common ratio of 2. My explicit formula for the situation is going to be a sub n is equal to 3, which is our initial value, multiplied by 2, which is our common ratio, raised to the n minus 1 power. That leads us to our last problem, and this is called an error analysis problem. So Tyler's given a function, and we've got to figure out if he's correct or if he's incorrect. So it says Tyler's given the function y equals 3/4 times 5 to the x power plus 2, and needs your help to explain each part. For part A, Tyler says that the function is a growth due to the change factor of 5. Is this correct? Well, I know my change factor would be my b value in my exponential function. And remember, we've got y equals a times b to the x minus h power plus k. If I'm looking at the initial function, I do have a change factor of 5, so Tyler is correct. And this is a growth because 5 is greater than 1. For part B, Tyler says the function has a vertical stretch by 2. Is this correct? Well, our vertical stretch or shrink is going to deal with our initial value. And our initial value is 3/4. So this is incorrect. This is going to have a shrink, so a vertical shrink, by 3/4 because 3/4 is less than the value of 1. And then part C is going to deal with our horizontal asymptote because we're looking at a vertical shift of either up or down. And part C says that Tyler thinks the exponential function shifts down by 3/4 unit. Is he right? Looking at the function that was given to us, we have our horizontal asymptote at y equals 2. So that's a k value of 2. This, instead of not being a shift down, this is going to be a shift up by 2. Because our k value is equal to 2. All right, guys, that is everything that's going to be on your Unit 5 test. Remember to study and ask questions.